Hi, everybody. Welcome back. It's been a long time. I didn't give you any video and session and post it here. So today I'm gonna continue on where we left off. I remember in the last session we talked about Edge and we talked about NSS design, including ESXi host preparation and edge creation and edge preparation. So in that session, I talked about how you connect your edge links, including internal links and external. I mean, how to use admin profile and some of the other things, and how to leverage Paul group to build up your just your edge design. So today I'm gonna give you a lab on how to create edge creation, and also we can have a pretty small evaluation or verification by using the T1, creating a T1 allocation or T0 allocation onto your edge or your edge cluster. So without further ado, let's dive right in. So firstly, I want to give you the lab topology and guide you through the whole edge creation process and the steps. And also, you have to think about how to create your edge according to the customer needs or like a POC requirements. For example, here's a lab topology here. We have a external one, external two as external router, where we have unique, or we have the only exit for NSS to use for the north-south traffic. And also we're going to create edge. So in the last session, we talked about edge and edge cluster. So how you put your edge. Normally, we put two edges into one cluster. So you can put more than two into the cluster, depends on what you need and your design. So here within this lab, we have to, today, we're gonna create two edges, and also put T1, every T1 onto edges respectively. So let's take a close look at the VM edge, VM mode edge. So we, as a review, because we have talked about that in the last session, and here in today's lab, how are we gonna create our edge, our edge? So we have, this is our model. So we create our edge according to this model, or to just, align with NSS standard or best practice. So here we have a VLAN 200, VLAN 300, VLAN 400. 300 is the same as left leg. I just said left leg, right? And VLAN 400 means the right leg. So we have two VLAN-based traditional VLAN for uplink to the external routers. So VLAN 200 is used for tunnel transportation, for TCP/IP tunnel transportation, you know. So we have Geneve, we have VXLAN tunnel. So within the ESS host, where we gonna put our edge onto, and we just need P1 or P2 or two additional physical adapter or network adapter. So hopefully P1, P2 is a new two new ones, because if you imagine that if you are given a POC environment, or if you have a POC testing, and maybe some of the ESS hosts, you have to deploy, and also there are some of the existing physical network adapters that are used. So you have to create, or you have to find out some of the new network adapter that in which way will be safe or in a best practice. So for existing VDS, where you create a new VDS, and on this VDS, you have to create two trunk port group, because you can see that in this diagram, trunk DVPG-1 port group is directly connected to VNIC 2. So from the edge point of view, every edge node has 4 fixed adapters, VNIC 1 for management uses, VNIC 2 and 3 for traffic, for T0, T1, or logical routers traffic. So VNIC 4, now mentioned here, is for bridging. Sometimes you have to create bridges between the two VLAN, or between the overlay segment or other segment, which is what we call bridges between the two segments. So most of the time we don't need VNIC 4 for bridging, so we just emphasize VNIC 2 and VNIC 3 for routing uses, for forwarding, for routing, normal routing uses. So trunk 1 consists of 2 VLAN, right? 200 VLAN 200, VLAN 300, and VNIC trunk VNIC DVPG-2 includes two VLAN 200 and VLAN 400, and this link directly goes to the VNIC 3, and this link goes to the VNIC 2. So that means from different layers, that's what I said, we have load balancing and redundancy mechanism for you to for NSS edge to manipulate the traffic in different contexts, or when it fails, or when something goes wrong. So there's a multiple layer redundancy right here. So we're gonna create those kind of virtual link or physical link in this lab. And another thing I want to mention that in the latest standard or latest model for creating edge, we only have to create NVDS, one NVDS. So imagine that, so or just something will ring the bell. So we from NSS 4.0, we don't support NVDS. So here's the NVDS. So we don't support NVDS on the host on the host ESSi host on the host, not in the edge. So for every edge, we still use NVDS inside every edge. So that's a little bit different and something you need to know about. And in the previous model, we recommend, for example, for NSS 2.4 or 3.0, we recommend using 3 NVDS. So nowadays, we just recommend 1 NVDS in an edge node. So just be careful about that. And just here's the steps. I don't want to talk about every step in details. I just guide you through and take you through the whole creation process. Okay, so over to the environment, our lab environment. Here we just already pulled up Windows for this is vCenter. This is NSS. So when you are given a new environment, or if you have a POC, you have to check all of the things you should know, then create something or just create an edge or like in this case. So here we have 2 clusters and a management cluster. We have 2 ESSM hosts, and for compute cluster we also have 2 ESS hosts. And so if you're new for the whole environment, you have to look at the networking configuration and see the VDS, existing VDS, and also some of the NIC adapter that have been used. For example, here is a 6 uplinks. So some uplink have been used, right? 1, 2, 3, and so you have to choose remaining uplink that are not used. That will be pretty safer for you, and for the whole POC, that'll be nice for the whole process. And let's look at the management cluster, these 2 machines, because we are going to create edges onto this two. So here we have a networking, and we try to check up on the port group. So this port group is using uplink 1, and this group is 5, uplink 5, uplink 6, and this is 2. So 1, 2, 5, 6 were used. So we have to use 3 and 4, uplink 3 and 4. So that means if when you start to create your edge, so just you need to negotiate and have a conversation with your customer and have them prepared well with this uplink. For example, plug it into the Recomon switches and just finish configuration of the external router or Recomon TOR switches. Interface configuration, you have to finish that, or a customer have to finish the configuration ahead of time. So uplink 3 and uplink 4 are required to be a trunk. Only the trunk is enough for us for NSS. So there's no need for requirement of port channel or aggregation, lag, LAG sort of things, port bonding, or those kind of similar terms. So we just need a normal trunk. It's okay for us to use. And the same way, you have to check the number 4. So the 3, so identify what link you're going to use for your edge node. So uplink 3 and 4 will be chosen. Okay, let's go head over to NSS. So for NSS, I already build up a compute. So for host transport node preparation, we have finished this transport node compute transport node preparation, and then here we have to add our edge node. So before add edge node, we have to look at our uplink profile that are gonna use within the edge node creation process. So in general, you have to add your user uplink profile for my uplink profile, blah blah blah, and then scroll down and just right here, just type in uplink -1, uplink -2. So that means we are going to build 2 tunnels between the compute transport node and our edge node. We're using 2 tunnels for redundancy and also for load balancing. So you have to choose load balancing source or load balancing MAC address. Either is okay. Then you add something we call the named teaming policy. So here we, for example, VLAN 300, right? The uplink 1. That means for VLAN 300, we just we just can use this uplink 1 as an active link. We don't want we don't want to use uplink 1 and uplink 2 for load balancing for VLAN 300 uplink traffic. That's so maybe we can go back to this, right? So 300 is only for, from edge point of view, 300 is only for uplink 1. So uplink is a attribute and property for this NVDS. So every NVDS have to have a corresponding or associated with the uplink profile to create those kind of a redundancy or just virtual connection relationships. So, and 400, we have to 400 and uplink 4. Sorry, uplink 2. Then you have to change your transport VLAN. This is a TCP IP VLAN, TCP tunnel VLAN. For example, 100 is now 0 because this is a lab environment. So transport VLAN is 0. That is you have to create your uplink profile ahead. So if you look at the default uplink profile, you can say there are two groups of them. One group, one is for, sorry, just host switch. Host switch means host transport node. They just can be used on the host switch, host transport node preparation. And there are another group with edge, three uplink profiles for in this edge group. So we can use a multiple VTAP uplink profile because when you open up this is the same, right? This is the same with what we created. Uplink 1, uplink 2, and the uplink 1, uplink 2 is the same. So you can use the default one if you don't want to change your tunnel VLAN ID. And also this is another one you want to use, but this is only one tunnel without any redundancy. So we just use today lab, we use this multiple VTAP uplink profile for creation our edge, creation of our edge. And another thing I want to mention that just we try to create this diagram right today. So we have to do something on our VDS via vCenter. So here we have VDS. Let's look at our VDS right now. This is VDS name, DVS SA data center. And this is uplink. So we have to create our two new for group. For example, this is trunk 1. and we just use 2. Then VLAN, we choose VLAN trunking because it's a trunking. Next, finish. And we also got another one, trunk 2. Next, 2, trunking. Next, finish. Then we finish building this 2 port group, but we have to have association and just kind of manipulation with, or just mapping with the, physical P1 and P2. There's a active standby relationship between the port group and the physical adapter. So we have to tune these parameters on the port group configuration menu. So here we edit this trunk 1 and open up a teaming and the failover. So here we try to modify this. For example, we have to put this move down, yeah, and we put uplink. Sorry about that, just a little bit breaking up. We select this uplink 3 and move it up to the active link. So we only need to have this only uplink 3 for our active link, and 4 as the standby link, and 1, 2, 5, 6 as move down. Sorry, just move down. Move down. Move down. So we don't use uplink 1, 2, 5, 6, but we just use uplink 3 and 4. Oh, right here. So this is what I want to config. So active link will be uplink 3, standby link will be uplink 4. Okay. And same way we modify the trunk 2. Five, 6, 1, 2. Move down, move down, move down. Move down, move down. Okay. And this time we put uplink 3 down to standby uplink group. Yeah. Active will be 4, standby will be 3. It's trunk 1 and trunk 2 totally opposite. Okay, it's okay. This step just we just build up this. Sorry, just build up this layer's redundancy or assignment. via this previous procedure or configuration. Now we can continue on creation our edge node, and this one edge node here, add edge node 1 and edge node 1 medium form factor. We choose medium size, and next admin. Let me just VMware copy. Paste, allow SSH, paste, and allow root. Okay, and next. Compute manager, choose vCenter, and management cluster. Okay, and resource pool. If you want to manually assign this edge onto the number 3, ESSi 03, you can do this. And data store, you just choose your data store storage. Then next. Then management IP, and we have to use this one. 172.20.10.61. Default gateway will be 10.10. Yeah, default gateway will be 10.10. And select interface. This step is to assign your edge management interface to your outside or external page or page group management port group on your BDS. And leave them blank, and here enable UPT mode for data path interface. What does UPT mode means? It means that UPT is related to GPU. So the latest news for NSS 4.1, we finished tested the GPU on 2 types of GPU card, GPU adapter for NSS forwarding and routing uses, and also this GPU on NSS also support DFW feature. So DFW feature will be offload to the specific or particular DPU network adapter. So that means that, so here, in this case, UPT mode is one type of DPU layer or encapsulation, or just, a mechanism for NSS to offload their task and some of the tasks onto the underlay network adapter. So just leave it as before. Finish. And here is a very important one. Very important. So here you can So as I mentioned earlier, now for standard model, we just need to configure one or create one NVDS switch. That's okay for edge to use. So transport zone, we choose default one and overlay and the VLAN transport zone. If you have your own transport zones, you can choose your transport zone. And also, sometimes we need to like this. I forgot something. Just this is so you should be careful before creation or creation of your edge node, because something they just invoke some of the other parameters or profiles, things like that. So here we just I want to add our zone. Commonly we create uplink TZ for left leg or for uplink, the two uplinks. So we then here we not only do we have to use VLAN overlay transport zone and VLAN transport zone. Overlay transport zone is compute ESSI host or compute transport node. The overlay transport node transport zone is on the ESSI host transport node, and VLAN transport zone is also used on the compute transport nodes. Commonly we have to create a new transport zone for uplink, only for edge node uplink. I mean the uplink here is left leg or left seg and right seg to uplink the right to the external routers. So we put the left leg or we put the left seg or right seg into this unique particular transport zone. We call it uplink TZ, TZ, and we choose VLAN type and just put you team -1 because we remember let me show you that. Let me show you a system profile. So we want to use the default, this one, edge multiple VTAP, right? So in this definition of, in this uplink profile, we have named the two additional policy. So name the teaming -1, teaming -2. So we want to associate teaming -1 to a a specific real VLAN or specific segment, but this segment belongs to a transport zone. So we have to correlate the transport zone, left seg or segments, and the teaming -1 name, and also uplink. We want to correlate 4 objects together. So we can build up this kind of structure here. So we want our VLAN 300, which is a left seg. Traffic directly goes to the VNIC 2, then send out the VNIC 2 directly to the transport trunk 1 per group. And for VLAN 400, we want them to go through the VNIC 3 and then go out. So that's a particular, we are going to, now we are creating this kind of structure now. So we have to associate some of the objects together. So to build this structure. So now just remember this name. What you named the teaming -1, teaming -2, or you using the default one, you have to use the teaming -1, teaming -2. So here, so just kind of like we calling or invoking this tool, or associate this tool onto this DZ. Then we put the left segment and right segment into this uplink TZ. So these 3 are finally associated with each other. So add. A little bit confusing here, so you have to have some experiment. So you use your multiple edge, multiple VTAP uplink profile. So what is an edge node for? Edge node is the purpose of the edge node is to connect overlay transport zone and VLAN transport zone and uplink transport zone. So edge node is kind of like aggregation point for the 3 transport zone and the corresponding traffic. So IP association is IP pool, and also we just already created the IP pool. And here, teaming policy uplink mapping is mapping because you are using this uplink profile. In this profile definition, we have defined uplink -1. We have the and the uplink -2, right? So now we have to connect uplink -1 to the this edge node fixed NIC and per group is a trunk 1, right? And trunk 2. So we are building that structure in the picture. Save. So finish. So now all the parameters were given. So just finish. Waiting for the creation. So you just click on the refresh. Normally it takes 5 minutes or 5 to 10 minutes. So we add another one, add two, and add two, medium size, and next. Then see, all size the same. Pause and enable this next. And this we choose VC and management cluster and host. Here we choose 04 and data store. We just guarantee that you put a nodes, a edge node VM onto different or unique ESXi management host. So, right here, static. Just put this IP address. Here. Then we give default gateway. Then select interface. Select interface with port group for management. Next. Here we same parameter we have to give and uplink dash tz. Okay. We choose. Oh, sorry. Then we choose. We select add multiple an IP address, IP pool, then IP pool, select trunk 2, now trunk 2, trunk 1 and trunk 2. Finish. So guys, after 10 minutes waiting, these two guys have been created successfully here, right here. So just if you want to have some detail, just click on the name. Then you have some detail, monitor overview sort of things. And also you can, if you want to learn more, you just can SSH or telnet into the two, sorry, just this one. I just already open up, just SSH into the edge one and get a logical router. So here you have some default logical router. We don't have any logical router assigned to it, right? So just give you tools and clues on this, and then we try to evaluate this. Oh, sorry, just we just next step we just we have to put this edges into the cluster. We just build a cluster 2, cluster 1. It's easy for this step. So the most important or critical one is the last. So just creation NVDS or filling a lot of parameters for the step in the last step. So add. So we put 2 edges into the cluster 1. So now we head over to networking and try to add T1, try to add a 1 logic router. So here, HA mode, T1 HA mode is, if you remember, I mentioned earlier, T1's HA mode is active standby only. But from NSS 4.1 or 4.01, there are some additional features, which is called service, a stateful service redundancy, or a stateful service load balancing mode. So, for example, they just well, I'm going to talk about this new feature, stateful service load balancing for logical router in the future, in the coming future, very soon. So you just add some of the HA mode onto T0 and also onto T1. Just make sure that if you have some of the stateful services like NAT and NAT, address translation and also firewall. So there's some session table and some of the stateful table and database they have to maintain in real time. So the asymmetric routing and asymmetric traffic, incoming traffic and outgoing traffic will be guaranteed within or through a unique particular point or a particular router. So that's what this is about. So T1 is additionally, T1 has 2 additional features options. You can choose active and distributed only. Distributed only, if you choose distributed only, so there's nothing to do with edge node. So as we review or brush up on our knowledge. So every logical router like T1, T0 has 2 segments, components. Sorry, 2 components. One is distributed router, distributed one component. One is a service SR, service router. Service routers are always assigned to the edge nodes. So this is active for stateful traffic traverse. So we just select a traditional one with for active standby, and we don't have any T0 now. So cluster 1 and auto allocate edge is okay. Just give you a verification for our new edge. So round advertisement is we'll talk about, we'll get into that in the next video or lessons for this options. Not a NAT, just connected segment. Just this is like a Cisco redistribute, neutral redistribute, or one-way redistribute comments or features. I'll just say no. I try to refresh and wait for T1 assignment. Head back to the net system and the node. We try to check the edge node. Yeah. So you can see that here, logical router, sorry. So logical routers 1. So our T1 has already been assigned onto the edge 1 and edge 2. Okay. So one T1 is active, one T1 is standby. So that's it. That's for if you can see get logical router. Here we have SRT1. This is newly built, right? This is the additional one for edge 1. So sometimes for troubleshooting, you have to go head over to this console CLI. Hey guys, welcome back to our NSS channel. This is Danny. So I just want to add something on this creation of edge node. And I just talked about the association with, we created a teaming uplink profile with 2 named teaming policy, which is associated with the VLAN 300 and VLAN 400. VLAN 300 is equals to, or just, we call it left seg, and 400 is right seg. So we have segment, we have VLAN ID, we have this kind of a structure, trunk 1, trunk 2 port group. We also have uplink profile for this NVDS for this edge node. And we also have teaming named teaming policy, which is teaming -1, teaming -2. we which is what we named. So you can name whatever you want. So the default one is teaming -1. So it's I want to get into that to give you the whole picture. So here in the last video, we created edge 1 and edge 2 successfully, and I put one T1 as a logical router onto this edge 1 and 2. And then we try to grab our resources. So when we check multiple VTAP, we have teaming -1, teaming -2, which is we call it named teaming policy. So teaming 1 will be associated with the VLAN 300. Teaming 2 will be associated with VLAN 400 just to build up this structure. So how do we create that structure further? So kind of like this is a preparation of creation of your T0, because when you create your T0 router, you have to create a lot of object and structure ahead, so their T0 can connect or T0 can invoke. So here's a segment, right? Here's segment. So we add segment. You want to try to segment uplink 1, or just for uplink 1, VLAN 300, and you don't have any gateway. You just later you just connect this segment onto your T0. Now you don't have T0. So transport zone will be uplink, right? Uplink -TZ. Remember, we use this on our edge node creation or on our edge node. So just segment. So you just subnet, just leave it blank here. Uplink teaming policy. Notice that here's the association or the hook of you just try the teaming 1 will be mapped to this segment. This segment will have 300 VLAN ID. That's the association. That's the entire association with. So this property of the segment for of your uplink is pretty important, because they in here the only way you can do is right here. You just create your association. Why teaming 1, teaming 2 appear? Because you select uplink TZ. Because if you look at the uplink -TZ's definition, you put your teaming 1 and teaming 2 as a named policy in the TZ definition. So here, teaming 1, teaming 2 appear. So it's everything is enough to save, and then you add again, add another, for example, uplink 2 and VLAN 400, or you can just write seg, right? Seg is another name, right? Seg, and right here you just select your uplink -TZ, teaming 2, VLAN 400. Then save. No. So adding the segment and editing or adding the property association to this right leg and your left leg are a very important step for creating creation this structure. That's what I want to now add for this video. Thank you guys.